So as you all know, the Terra and Vision conference has these 4 themes that you have all submitted your abstracts to, related this year to specifically to nature-based solutions. And the mission of our conference is to find the right, feasible, and viable solutions to make the transitions towards a society that will stay within the planetary boundaries. And for that, we need not only scientists, we need not only stakeholders outside of science, but we need to join forces with all the scientists, the policymakers, and industry. And this conference is aimed to do so, to find together these solutions for the societal issues of our time, using nature-based solutions. So we have the mission to promote this exchange between research, industry, and policy, and to try to come to an international, interdisciplinary collaboration and networking. So to bring together, as I already said, scientists and stakeholders with this same goal, and to enable the next steps that we need to make to come to a sustainable situation. In this, we should, of course, link to international policies, such as Sustainable Development Goals, the UN Climate Convention, the Green Deal, and the COP and the CAP. So, my name is Saskia Keestra. Sorry for this. I'm the main initiator of Terra Vision, which we started a couple of years ago, already in 2018. Before COVID, we had 2 editions of this conference, and this is the 3rd one. And in 2 years, or next year, and we're not, I don't remember what I said now. We are going to have the next edition in Granada, in Spain. So put it in your agenda already. So why do we do this also from my work at Wageningen Environmental Research, or at Wageningen University and Research? So it's important for us to have international collaboration, of course, but this we could, with scientists, we could use any other conference that we have many of. But this one, I thought it was important to organize, to especially get this collaboration with different scientific groups together, and different to allow this link between science and society. Of course, this conference was not only organized by me, but it was organized in a group of people that are coming from different parts of the Netherlands and different also internationally. So especially the 2 people that were very important in organizing this conference were Co and Margot, and they are from Rijkswaterstaat. So then please, one of you can just introduce yourselves and what Rijkswaterstaat does.
Cool.
Als je niet wegloopt, dan kan je.
Oké, nou dan blijf ik maar staan. So hello everybody, it's really nice to see all of you here in Utrecht, city where I live actually. And we are very happy, my colleague Co Molenaar and I, to be a part of this Terra and Vision community, and that we were able together with Saskia to organize this conference. And well, I'd like to start with some personal comments also, because what I want to share with you, what I think is really important, is actually that what I stand for is what I stand on. The soil and the soil system are really important actually for myself, and I also see it as very important for all our societal challenges and our welfare and well-being. And that's what my colleague Co and I've been working for already quite some time. And that's also how we met Saskia and Gerben to team up together as policymakers and scientists to put forward the importance of soil underneath our sustainable development goals, and also to find ways on how to put science into policy and how to make society a better world using the soil and its functions in a sustainable way. And our organization, Rijkswaterstaat, which is an executive agency of the Ministry of Infrastructure and Water Management, is also very active in this field. We have very long history. Our organization is founded in 1798 after some severe floodings and severe damage caused by that. The government of the Netherlands said we need some national coordination, and that's why our organization was funded. And it started actually as an organization to help construct waterways, canals, dikes, to secure water safety in a way. And also polder management was a big part of their tasks. In the time when Industrial Revolution came up, also highways, railways and buildings supporting all these became part of our tasks. And lately we also have as a task the environment. So what we focus on as an organization actually is to create sustainability for the environment, and we want to strive for an accessible, sustainable environment. We create sustainability, we strive for circularity because we manage a big, all the infrastructure in the Netherlands and all surrounding land and water. So there's a big task for us, and lately also climate adaptation, of course, becomes a severe subject of our attention. And how do we do that? Well, actually, collaboration is the key for our work, because as an organization, we cannot do it alone. We need science, because it's very science consuming what we are doing. Also dissemination, because we have to work with municipalities, provinces and water authorities. And so collaboration is really very important. Why is this conference so important for us? Because we need this knowledge, and we as a country, the Netherlands, faces big challenges. So, and we think we are not the only ones facing those big challenges, like sea level rising, enormous pressure on land, pressure on resources, and we also meet our boundaries, the planetary boundaries. We are facing it today. I don't know whether people came by car. There are strikes all around at this moment for farmers who have to go and meet the nitrogen regulations, and there's just a fight for land, because we need the land for housing, we need the land for farming, we need the land for recreation, for climate adaptation and so on. So you can imagine this big pressure also asks that we go and act. And time for ordinary solutions, technical solutions is gone. We do not have the possibility to go on and try to optimize our solutions. What we actually have to do is that we have to look differently, we have to think differently, but also we have to act differently. And we have to find an approach where we can, with new focus, try to find solutions. And that's why this nature-based solution conference is so important, and especially that you are all from different backgrounds, because we need to look with different focus in many ways and try to team up and learn from one another. Our organization already developed quite some astonishing nature-based solutions, but we also realized that it cannot be done alone. You need one another. And we are very proud also that last week he won a prize for collaboration by the Environmental Agency on Flood and Coast Excellence for an international guidelines on natural and nature-based features for flood management. And these are examples we'd like to share with you. Also with the excursions we'll have this week, you'll find some of those examples. And what I'd like to is I want to invite you all to learn from one another, inspire one another, go and meet one another and have just a fun and great conference. And I'll hope to have discussions with you over the days and see some very nice examples, and I wish you a very nice and fun conference. Thank you.
Thank you. Yeah, so before we go to the other major are here invited. We're going to address by Schotting, who is a. But before that, I would like to thank also the other organizers of the conference. Both my colleague in Department of Environmental Research, as well as working at the Amsterdam Institute for Metropolitan Solutions. Thank you. Then we have Artemis Serda, who's sitting there. He was the guy who's going to shoot lots of pictures and videos of you over these 2 days. He's from the University of Valencia. And we have 2 more people. We have Walter Leepart, he's from Australia. And then we have 2 people that are not here, but were also involved in the organization. Carla Ferreira from the Stockholm University, and Yannis Daliakopoulos, who is from the Hellenic Mediterranean University in Crete, in Greece. He could not be here because he just became father 2 days ago. So I think that was a very good excuse not to come. So now we have here Ruud.
Let me see. Thank you very much. So, a warm welcome to Utrecht University. Terra and Vision. My name is Ruud Schotting. I'm a professor of quantitative water management at this beautiful university. And I'm also chair of the environmental hydrogeology group. I was approached by Saskia with the question, is it possible to host the conference? And of course, we're willing to do that. So that's the reason you're all here. First, I would like to say a few words about Utrecht University. And then I would like to focus on the subtitle, which is over there, which is Nature-Based Solutions to Facilitate the Transition for Living with the Planetary Boundaries. And I'm going to give you one really nice example where I think that we are using the facilities that nature offers to help us solve a really big problem. And it's a challenging thing, and it's very unorthodox, and it takes me 10 minutes to explain this to you, I hope. Okay, so Faculty of Geosciences, Utrecht University, very old, 1634 over there. We have plus 35,000 students, that's a lot, and quite some staff. And we have 4 departments within our faculty: Earth Sciences, Physical Geography, Sustainable Development, and Social Geography. So if you see this bunch of disciplines, then it's quite logical that we organize this conference over here, at least that in my opinion. Now, the last conference I attended was ended basically March 2020, and it was also in Utrecht, and it was the Nederlandse Aardwetenschappen Conference. And during the conference, we were forced to leave the building and go home, because there was an announcement of the government regarding COVID, and that was the end of it. And since then, I didn't have any holiday abroad until 2 weeks ago. I didn't attend any live event, conference, I mean. And now, so for me, this is the first time to be in this environment again, and it feels for me really very good. Okay, so nature-based solutions. I listed a few typical issues related to this. Now, out-of-the-box solutions there in general. They're unorthodox, so usually it's not the first thing you think of. They're sustainable usually. Now, there's a low environmental impact, which we like. Usually they're economically cheap, so I mean in the sense of money-wise. And there's this problem of getting finance for your research, and usually it's they call it high-risk research, because it's not completely clear whether it's going to work. And then it's difficult to get funding. So now I'll give you one example. Many years ago, there was an idea by Deltares, which they called smart soils. I see faces from long ago from Deltares. You remember these smart soils. Well, it was really a nice idea. And the basic idea was to change the physical properties of a soil. So the hydraulic conductivity or the porosity or whatever. And for a certain purpose, okay? Usually, for Deltares, this was civil engineering. And now they were, in some sense, quite successful because what they were doing was using bacteria that are either already present in the subsurface, so present in groundwater, for example, present everywhere, or they were introducing certain bacteria and certain chemicals such that you could alter the properties of the subsurface, of the soil. Now, there were two methods to do this. Biosealing, where you use the existing bacteria that are naturally available, and biogrowth. Now, I would like to focus on the first one because now this is a summary of what it does. So you use microorganisms that are basically available everywhere. You use nutrients, sugar, you could say, a very simple, cheap substance. You add this to the natural flow paths, and you get growth of biomass, and this changes basically the properties of the subsurface, just in a nutshell. And now, so the idea is very simply explained over here. What we see here is a sea container. We all know this. They buried this one over here. So they took away the groundwater surface level, and they put this sea container, and they made an artificial leak. They filled this with sand again. The groundwater table came back, it's the horizontal line over here. And of course, because of the leakage towards this container, you have converging flow lines towards this leaking point. Okay, that's the idea. Now, then the idea is to, so you have these existing bacteria over there, you add the nutrition, and this will be transported by this converging flow towards this leaking spot over here. And what happens here is that biomass is formed, and this clogs basically the porous medium. So within 2 weeks, this artificial hole in this sea container was basically closed, so it was clogged for flow. Now, there were other applications for the high-speed railway aqueduct, they used it, and somewhere with the dam. Okay, but these were all civil engineering applications. Then for a long time I didn't hear anything about it, and then I was invited to go to China for a mission because there was a huge drought. So for 1 year there was no rain whatsoever. And here we see the Prime Minister of China visiting the province of Yunnan. Yunnan is one of the poorest provinces of China, and they had a big problem there with this drought. So the mission was with all kinds of experts, and I was the groundwater expert. So they said, okay, let's go there, let's see what we can do. What can we think of? And it was very difficult because you saw very poor people, no water whatsoever, and but it is so this is Yunnan, and then some pictures of what was going on over there. Now this is of course unbelievable that this fish is stuck in dry clay. Okay, now the problem is clear, and while driving there, I thought, so this is the mission. It was already in 2010, and the ultimate goal was to prepare Yunnan for droughts, because you can prepare yourselves for floods, which we do in the Netherlands, Delta Plan, for example, but you can maybe also prepare yourself for serious droughts. Now, so the idea was to do the following. So if this is a cross-section of the subsurface of Yunnan, and then we have a topsoil layer, and we have fractured rock over here. Now in the Netherlands, if we have recharge, rain, then it by gravity it enters the subsurface, and then because there are clay layers, a water table will form. Okay, and so basically you store water in the subsurface. Doesn't happen here because you have this fractured rock. So this topsoil is on top of fractured rock. So all the rain that comes into the topsoil disappears in the fractures. So there's no water table, so you're not storing water. So the idea that came to my mind was a very weird idea. I thought, why can't we use this idea of biosealing, introduced by Deltares, at this large scale? So can't we use the bacteria to clog the fractures such that we get an impermeable layer, yeah? And we can build up a groundwater table, and then we can store large quantities of water. Now, here's a Mickey Mouse cartoon. So this is the fractured rock, this is the unsaturated soil, and now whenever it rains, then you get the following picture. So the water enters the unsaturated zone, and it disappears in the fractures. So the groundwater table will be in the fractured rock, but maybe 100 meters below subsurface. So very inaccessible, so not usable for very poor people. Now the idea was to add basically at this surface nutrients, so sugars, for example, nitrolase, we call it, and then it's carried by the rain into the impermeable, over in the unsaturated zone, and then it is transported to these fractures, so you get this converging flow, which is a condition that we need, and then you get the creation of biomass. Then there's another process which is about capture of very small fractions of minerals, etc., which is going on, which I'm not going to talk about, but this is the simple version of it. Now, so we made a 2-minute movie, so that's also almost the end of this story. Here we go. I hope it works.
In February 1953, the Netherlands faced an unprecedented natural disaster. The province Zeeland was flooded by the sea. After this disaster, the Dutch government decided to take drastic measures to avoid such a tragedy in the future. The Delta Plan was born, a beautiful example of flood preparedness. But what if you live in a part of the world where long periods of drought occur? For 8 months, no fresh water available for drinking water supply, cattle and irrigation. Yunnan, one of the poorest provinces of China, faces this type of disaster frequently. How to be prepared for long droughts? The answer is quite simple. Collect water during the wet season and store it for use during the dry parts of the year. Current solutions, such as surface storage tanks and artificial lakes, are too limited in capacity. How to store large amounts of fresh water for use in times of drought? The answer comes from extremely small creatures that are not even visible to the human eye. Natural bacteria that live in the subsurface. In Yunnan, the topsoil sand layer is on top of fractured rock. During the rain season, rain enters the topsoil layer and disappears into the fractures. While it rains, nutrients are added at the surface. The flow transports the nutrients towards the fractures where biomass is created. The fractures are clogged, implying a groundwater table is formed on the topsoil layer. Fresh water is now available. An unconventional idea, but if it really works, it could change the lives of millions of poor people living in those dry parts of the world where fresh drinking water is not something obvious.
Okay, so in my opinion, an excellent example. It's extremely cheap. So you use the waste material of potato industry or whatever. So these nutrients are widely available. The bacteria are there because they are provided by nature. We don't have to bring them there, so they're harmless, at least people tell me. Now you can apply this, of course, in large parts of the world. Of course, provided the atmospheric circumstances are optimal, you could say, and you have this problem. So long periods of droughts, and then after that periods of rain. Now the big problem, of course, this is high-risk research. So how to get funding, and I know all about it. It took really a very, very long while. to get people convinced. We did the open mind competition, we got some seeding money, etc. Oman is now investing, Portugal is investing, and so slowly we're trying to get up to a pilot. So in the lab we can show that this works, and now we're trying to scale this up to a pilot product. So now this is
In February.
My last slide. I think let's start now. So the conference already started, and I don't think there's any time to waste. So I wish you a very pleasant conference and a very pleasant stay here at Utrecht University. Thank you very much.